Addition, subtraction, multiplication, and division. These are four basic operations in mathematics. In this video, we are going to study about closure property of this operation on a given number set. What is closure property? A set has closure under an operation if performance of that operation on elements of the set always produces an element of the same set. Let's try to understand this. A set. A set could be whole number, natural number, integers, or any number set. Now, a set has closure under an operation. Operations could be any operations. Let's say we are performing addition operation. So according to this, if you pick elements from whole numbers, let's say we are picking a and b, and if you perform an operation that is a plus b, if a plus b is always a whole number, let's say a plus b is giving you the result that is c. If c is always a whole number, this is the key. Then we can say a set has closure under this operation, that is set has closure under addition. Okay, let's start with whole numbers. Whole numbers w is equal to 0, 1, 2, 3, 4 up to infinity. Now let's pick two whole numbers 1 and 3. If you perform addition operation on these two numbers, the result that is 4 is also a whole number. In fact, if a and b are whole numbers, a plus b is always equal to whole number. Hence, whole numbers are closed under addition. Whole numbers are closed under addition. Let's check whether whole numbers are closed under subtraction. Okay, let's pick two whole numbers 6 and 4, and let's do the subtraction. That is equal to number 2. Here 2 is also a whole number. So in this case, the subtraction of two whole numbers is giving us a whole number. But how about if we pick different whole numbers 7 and 11? 7 minus 11, that is equal to minus 4. Here minus 4 is not a whole number. That means if a is a whole number and b is a whole number, a minus b may not be always a whole number. Hence, whole numbers are not closed under subtraction. Okay, how about multiplication? Let's multiply two whole numbers. 2 times 4 is equal to 8, 0 times 11 is equal to 0, 7 times 20 is equal to 140. In fact, if you pick any two whole numbers and do the multiplication, the result is always equal to whole number. Hence, whole numbers are closed under multiplication. For any two whole numbers, the multiplication is always a whole number. Hence, they are closed under multiplication. How about division? If we divide two whole numbers 3 and 11, 3 divided by 11 is equal to 3 by 11. This is a rational number. So the division of two whole numbers is not producing a whole number. Hence, whole numbers are not closed under division. Okay, so far we have studied the closure property for whole numbers set. Now let's look into the closure property for integers. Integers are closed under addition. If you add two integers, the result is always equal to integer. Integers are closed under subtraction. The subtraction of two integers is always an integer. The subtraction of two integers is always an integer. Hence, they are closed under subtraction. Integers are closed under multiplication. If you multiply two integers, the result is always an integer. How about division? Integers are not closed under division. As you can see, in this example, we are dividing these two integers minus 7 and 2, and the result is rational number. Hence, integers are not closed under division. Alright, let's check the closure property for rational numbers. Rational numbers are the numbers of p by q form, where p and q are integers and q is not equal to 0. If we add two rational numbers 5 by 7 plus minus 2 by 3, then the result is also a rational number, 1 by 21. That is a rational number. If you add two rational number a and b, the result is always a rational number. You can try out few rational number and verify. Hence, rational numbers are closed under addition. Rational numbers are closed under addition. If you subtract two rational numbers 5 by 7 minus 2 by 3, that is equal to 29 by 21. Subtraction of two rational number a minus b is always producing a rational number. Rational numbers are closed under subtraction. How about multiplication? If you multiply two rational numbers, the result is also always a rational number. Hence, rational numbers are closed under multiplication. How about division? In this case, we are dividing two rational numbers 5 by 7 divided by minus 2 by 3. If you solve this, this is equal to minus 15 by 14. Here, this is giving us a rational number. In fact, for most rational numbers, the division is always producing a rational number. But how about this? Let's divide 5 by 7 by rational number 0. As we know, division by 0, that is not defined. Hence, division of two rational number is not always producing a rational number. In this case, it is not defined. Hence, just because of this, rational numbers are not closed under division. If divisor is other than 0, then it always produces a rational number. But if divisor is 0, then it is not defined. Hence, rational numbers are not closed under division. Okay, so what we studied? For all given sets, natural number, whole numbers, integers and rational numbers, addition and multiplication, these two operations are closed for all this number set. If you look into this table, you can also observe that division operation is not following a closure property for any of this set, and subtraction operation is only closed for integers and rational number. In this video, we'll learn about closure property.